Welcome. Today we're going to talk about the angle of repose measurement when utilizing the Hosokawa Micron powder characteristics tester model PT-X. Once you have set the software so that you have your main screen displayed, we are now going to open the angle of repose measurement icon. What's displayed here is the actual setup of the componentry. In order to set the machine up, we first must open the polycarbonate door, and we're going to follow basically the instructions here that are displayed on the computer window. We're going to place in the sieve holding frame, set the sieve. The sieve should be large enough to permit 100% of the material to pass. We will then also place in the location the cup extension. That gives us sufficient amount of material so we can perform the entire test. At that point, we're then going to place the plastic, it's a plastic ring, however, glass funnel in place by using this holding bracket. Make certain that it sits down, and then locate it by the two arms and place the funnel in location. Last but most importantly is the angle of repose platform. We typically insert this in the back holding socket and rotate it clockwise. Now we have the componentry set up as would be indicated on the screen or in the software of the PT-X. Once the components have been set in place, what we're going to now do is press the next button, which as you can see here is in the lower toolbar. At this point in time, the software is indicating that we must load or charge the material into the cup extension. Typically what I do is I hold my finger at the base here to prevent 100% of the material from passing, and I will introduce approximately about 3/4 of the cup with material. So it's approximately to this location. Once that is done, remove your finger and advance the software by pressing next. Now in this location here, what we're going to do is we're going to set up the vibration. This platform will vibrate. It ranges in vibration from anywhere between 0.5 millimeter to 3 millimeter. My recommendation, depending upon the size of the product, is to actually reduce the amplitude of the vibration, and that is just by simply putting your cursor onto the square and then backspacing. Now additionally, the defaults are set up such that you have 170-second vibration time and you have a 10-second reduction in vibration or slowdown period. You can go back into your default settings and change those. However, I wouldn't change those in the very beginning when using the machine. I would change those after you've had an opportunity to understand your powders a little bit more. All right, so what we're going to do is we're going to close the door. However, I do want to show something. If we press start, notice on the screen that there will be a window that pops up that will indicate that the protective door is open. You must close the protective door. Okay, so once it closes, you also see then the lamp or the color of the button changes to OK. So now what will occur is the vibration will begin and the heap will begin to build. As you notice how the heap is building. What you want to do is you want to continue the process of building the heap of material until the material overflows the platform around the entire diameter. Once the heap of material has satisfied the diagram, as you see here, that has been displayed after the slowdown period has terminated, what we want to do now is to, first of all, confirm, yes, we do have a full platform of material. Then what we'll do is we will press next. And next will take us to the next start or position, and that is where the backlight illuminates. and we begin to take a picture to determine what the natural angle of repose is. As you can see on the screen, there is a diagram that will display the angle. Please note that you're looking at the highest point of the heap to the diameter of the platform. In this case here, we're looking at 35.4 degree angle. Provided you're satisfied with that, press the next button to proceed to the next test. The diagram that's displayed, or the chart that's displayed, shows number one, the angle, and number two, the index. That's the Carr index. In accordance with Ralph Carr, who developed these methods back in the mid-60s, angle of repose is defined as the direct indication of the potential flowability of material. And as you can see by the heap of material, it has a natural angle of particle flow. So when we're looking at the Carr index for flowability, what we have is a set of charts. And those charts are displayed as such. And if we look at the angle of repose, in this case here, if I remember correctly, 35.4, we're actually in a 20 index. Now, please bear in mind, the index is a rule of thumb. When dealing with particular products that you need preciseness, always, always, always look at the actual angle, because the instrument is set up, as Ralph Carr developed, to average out. So 0 to 4 would index down, 5 to 9 would index up. Once satisfied with the angle of repose measurement, we're now going to proceed or advance within the software to perform the angle of fall measurement. The angle of fall measurement is performed by applying 3 equal G-force taps to the heap of material that's already in place on the platform. To do that, we're now going to press the next button, and I can't see my mouse, there it is, and we press next. So what occurs now is the tapping mechanism is elevating within the cabinet, and as you can see, the heap of material is changing shape. Once the heap of material has finished they're being tapped, and we again have the same requirements that the material is fallen off the platform, we now can proceed with the software or advance within the software by pressing the next button. And once again, we go through taking the angle measurement. Okay. As you can see here on the display, we're looking at the highest point of the heap of material to the widest point of the platform. In this case here, we're looking at 19.8 degrees. Now, if you recall what I mentioned previously about the averaging, this will actually, if you look on the chart, which there is a similar chart to the angle of repose for the angle of fall, that will average up such that it will look at that angle as being 20 degrees and give you the corresponding index, which now will be displayed on the next screen of the computer by simply pressing next. So in this case here, we have 19.8 or 22.5 index value. All right. Provided you're satisfied with that, to advance the software, press the next button, and what occurs is you'll see a window pop up, which is actually the angle of difference. The angle of difference, quite frankly, is the differential between the angle of repose and the angle of fall. In this case, we're looking at a differential of 15.6, which then has a Carr index of 16. I'll go into the Carr index a little bit more so that you can understand how and why these index values are relevant and how they can help you in determining a very quick idea as to how well your powders flow. Angle of spatula is an easily determined property that will indicate the relative angle of internal friction of a dry material. A spatula is inserted into a heap of material parallel to the bottom of a pan. Then it either is lifted or the pan is lowered so that the spatula is exposed from the heap carrying material. What we will now do is refer to the next step and press the icon. By pressing the icon, the software advances so that you can get an idea as well as a descriptive method as to how to set the instrument up. As we have previously, we have the sieve holder, the sieve screen, which again is used as a flow control device, the cup extension. Then what we will do is we will insert the funnel and the locking clamp into place. And the spatula itself. We'll lock it into position by turning clockwise, and at this point you can confirm that the components are in place to perform this method, our measurement. We then press the next button. However, once again, the door being open, we cannot proceed until the door is closed, and as you notice, the platform has elevated. At this point, what we'll do is we will add the material. However, we'll use this gauge or guide to basically control and give you an indication as to how much material should be required. Okay. We'll now close it. And to advance to the software, press the next button. Once again, as mentioned previously, we have an amplitude of vibration of 1.5. In some cases, this amplitude is satisfactory. However, in many cases, you may have to change it. That can either be changed, once again, either in the default settings or as the software is operating. What we'll do is we'll change it here, and we'll just have 1 millimeter amplitude because we have determined in the prior tests that 1 millimeter should be sufficient to disperse the material. To move along, we'll press the next button, at which time the vibration will begin. And as you can hear, it is just a little bit too radical. Once the material reaches the top, we can stop the vibration. And this material flows a lot easier through this metal funnel rather than it does through the glass funnel. And then we'll press next. Notice the spatula had lifted from the heap of material, carrying with it the material that we'll call the first angle measurement. So in order to activate the camera, we'll press the next button, and we will take the first measurement. Also notice that with this particular model, the camera is high enough so that the gauge does not have to be removed. So, as we can see here, we have an angle on the first of 40.9. Again, with the Carr index values, they round up, so basically that's a 41-degree angle. And now what we'll do is we will press next, because with the angle of spatula, we impact the spatula such that the heap changes position once and only once. But that's all controlled by the software. Okay, we'll press next. And what will occur is we will watch the heap change. As you can see, it has changed its configuration. And now we press the next button. Next button is going to take into consideration the heap of material to determine then the second angle, which is 23.9, and let's take and identify what has taken place here. Okay, so the first angle was 40.9, the second angle is 23.1, giving us an angle of spatula, which is the average between the two, of 32. The Carr index value is based on the average value, not the first angle measurement, nor the second angle measurement. To Proceed through the to the next measurement. We press the next button.